Okay, this is chapter 6, electricity. This is actually kind of one of my favorite chapters in physics, just because we get to talk about things that, I don't know, I just like circuits. I don't know, it just kind of interests me. So we're going to start out, first of all, talking about electric charge, um, kind of get to the basics of what makes electricity before we can actually get into circuits and things like that. So before we can get into circuits, we have to understand the basic makeup of an atom. And especially since we haven't got to the chemistry portion yet of, um, things, we have to really kind of go and review here real quick. So hopefully we maybe remember that atoms, they're made up of protons, neutrons, and electrons. They have these three basic components. So if we go over here and look at the nice diagram of an atom, look here. You've got this nice nucleus, right? Center. That makes up the protons and neutrons. Protons, positive charge. Neutrons, no charge. Then they're surrounded by these outer things that are called electrons, which have a negative charge. Now the key here is that the positive charge of the proton matches the negative charge of the electron. So the protons and the electrons for a neutral atom equal out. So because these objects are said to have a no net charge, meaning that they have no charge, we call them electrically neutral. Okay, so that's just kind of some key ideas with the idea of an atom and that you have to understand with electricity. Alright, so something that we all are probably pretty familiar with because we've all been shocked a time or two. I know here recently in the classroom I've been shocked a lot, especially with the weather changing here, is static electricity. Static electricity is just where you get an accumulation of excess static electricity charge on an object. So basically there's a buildup of electrons on an object. So for example, if you take a balloon and you decide to rub it on your shirt for a little while, you build up an area of negative charge on that balloon, and then it gets attracted to the positive charges on other places. So maybe on your hair or wherever you decide to go and stick that crazy balloon. I'm going to cut away here for a minute and I'm going to show you a short clip on how like basically getting shocked by a doorknob or something like that actually works, like why you get shocked by a doorknob or something like that. So stay with me, we'll kind of look at that and then we'll come back and we'll look at some other things.
As you walk across the floor, you rub electrons from the carpet onto the bottom of your shoes. Electrons then spread over your skin, including your hands. As you bring your hand close to the metal doorknob, electrons on the doorknob move as far away from your hand as possible. The part of the doorknob closest to your hand is left with a positive charge. The attractive electric force between the electrons on your hand and the induced positive charge on the doorknob might be strong enough to pull electrons from your hand to the doorknob. You might see this as a spark and feel a mild electric shock.
Okay, so we took a look at the whole idea that if the reason that you get shocked by a doorknob is because, you get this accumulation of charge and you have that accumulation of charge in your finger, and so it's going to go over to the doorknob, and so that, when you do that, there's just such a buildup that, you get shocked. So that's the idea. Well, the idea that, of course, it's being transferred over. And so that's the idea of the law of conservation of charge. And that's where charge can, of course, be transferred, but it cannot be created or destroyed. whatever charge we have, whether it be positive or negative charges, whether it be protons or electrons, or even, I guess, neutrons in that fact, whatever we have is what we have. It can be moved from one place to another, but we cannot create any more. It's what we have is what we have. It's conserved. Okay, a couple of things about the force between the electric charges. What it depends on. How strong these two charges interact. So if you put two charges together, how strong they come together and interact depends on a couple of things. One, the types of charges you have. Okay, this is kind of a very important thing. And one, unlike charges. Unlike charges attract each other. So look over this little diagram that I have over here in the corner. If you have a positive and a negative, they're going to come together. Okay, so positive, negative, they attract each other. On the opposite spectrum, though, like charges repel each other. So if you have a positive and a positive, like in this picture over here, you have a negative and a negative, they're going to go away from each other. The distance between the charges. The distance between the charges, so the farther you pull these things apart, the weaker their force is. So the force decreases the farther apart they are. So if we try to put these a little closer together, the more they're going to like each other. The amount of charge, the more charge you have, the more force you're going to have. So these are all important factors that make the force of this overall charge larger. Electric fields. Every atom basically puts off an electric field, or everything puts off an electric charge. And basically what it does is, so notice that this positive charge here has an electric field, and it causes it to rather be attracted or repelled. So notice that this positive here likes to push things away, whereas the negative charge likes to pull things in. So that's an electric field of a charged atom. Compared to electrical forces, gravitational force is very, very weak. So if we start like kind of comparing, gravity, very weak. In fact, an electrical force, the interaction, the force between an electron and a proton in a particular like hydrogen atom is 10 to the 39 times larger than the gravitational force between these two particles. So electric force much, much stronger. So electrical forces, I guess you just need to understand, is a lot stronger than the gravitational force. Okay, a couple things. We already talked about conductors or insulators, but I want to make a key point when we get to this chapter that we talk about this in terms of electrons. So a conductor we're going to redefine, so at this point, as a material through which electrons move easily. So that's a key word there. Electrons move easily. So again, the best conductors are metals because again, electrons have the easiest movements. Remember we talked about in the last chapter that they have the ability to kind of move around and slap things. They can move around as much as possible. They're allowed to kind of go and do whatever they want to do. So again, the key word there is electrons. And again, we've already talked about insulators, but I want to redefine this as a material in which electrons are not able to move easily. For insulators, these are things that the electrons are held a little bit more tightly. Um, Plastics are good insulators. Again, because of the whole idea of the electrons being held more tightly. Okay, a couple of ideas we'll talk about. One is charging by contact. This is the process of transferring charge by touching or rubbing. So that's kind of the key thing here, is that in order to have charging by contact, you have to have some kind of obviously physical contact, hence the name. But it's the transfer charge by touching or rubbing. So you can rub two materials, you could transfer electrons that way, and that's charging by contact. The other one is a charging by induction. So the rearrangement of electrons on a neutral atom caused by a nearby charged object. So this would be where you influence another object by bringing a charged object near it. So you take a balloon, for example, rub it and bring it near it. So that is charging it by induction. So kind of the difference, charging by contact is that you're charging things by rubbing them together, so you're getting them all charged by rubbing. And then charging by induction is you maybe like rub the object, but then you brought it near another object, and then that object that you rubbed is influencing another object in order to charge it. So you're using your charging by contact in order to charge now by induction. That's kind of maybe a way of thinking about it. So here's some ideas to take away from. We're going to then journey on now into Ohm's law and discuss circuits and get into batteries and some other things.